Hello, geometry students. Today we're going to be talking about the Pythagorean theorem to determine the type of triangle that is formed. So in another video, we talked about the triangle inequality theorem to figure out if any three values would make a triangle. So let's take a look for review whether these values make a triangle. So we said that we needed to take the longest length, which is 13, and then compare it to the sum of the other two. So 13 is less than 17, so we can make a triangle. For square root of 12, 13, and 12, well, which of these values is the longest side? It has to be 13 because square root of 12 has to be smaller than 12. So let's take a look at this value. So 13 is less than 12 plus square root of 12. Square root of 12 has to fall between the square root of 9 and the square root of 16. So our factors are 3 and 4. And 4 is a perfect square. So when you take the square root of 4, you get 2. So even if we did not have the square root of 3 here, 12 plus 2 would be 14, making this statement true. Okay, so we are going to recall from middle school years that the Pythagorean theorem makes us square values. So let's practice squaring these values. So 5 squared is 25, 13 squared is 169, and 12 squared is 144. How about these values? We had the square root of 12. What does it mean to square the square root of 12? Those two operations are inverse of each other, so they would just cancel out, giving us the value of 12. But let's see if we expand this. If we have the square root of 12 squared, that's the same thing as square root of 12 times square root of 12. 12 times 12 is 144. And from our perfect square list, we see that the square root of 144 would be 12. 13 squared is 169, and 12 squared is 144. Okay, so let's go back to our middle school years. We said that if we had a right triangle, the legs were named A and B, and then the hypotenuse, the longest side of a right triangle that is directly opposite the 90-degree angle, we named it C. So C squared is equal to A squared plus B squared. And the reason I wrote it this way is so that the longest side would be on the left-hand side, just like we had done when we were trying to figure out the triangle inequality theorem. Okay, so we have 5, 4, and 3. 5 is the longest side. So let's see what the relationship is between 5, 4, and 3. So we know that we'll be able to make a triangle, but if we squared each length and add the two smallest lengths, how does that compare to the 5 squared? So 5 squared is 25. And what is 16 plus 9? 25. So that means that 25 is in fact equal to 25. And that means that we are able to form a right triangle. Now, if we have the values 8, 12, and 19, 19 is in fact smaller than 8 plus 12 because that's 20. Now, if we square each one of those, and you can take a calculator out for this, 19 squared is 361, 8 squared is 64, 12 squared is 144. Add those two up, and 361 is greater than 208. So what type of triangle would we form if the longest side, when we square it, is greater, sorry about that. 361 is greater than 208. What does it mean? Well, that means that we would make an obtuse triangle. All right, let's take a look at one more example. We have the square root of 213, the square root of 17, and 15. For these three values, I have brought out the two different calculators that you might be familiar with. This one might look similar to some of your cell phone calculators. This one is a TI calculator, and What I like about the TI calculator, especially a TI-84, is that I can see several numbers all at once. So let's take a look at where we're going to find the square root function. If you look here, there's a square root symbol in blue. To access that blue command, I need to hit the second key and then x squared. That brings out the square root symbol. And then I type in the value that I am interested in figuring out the square root of. So the square root of 213 is approximately 14.6. Now let's do again, second x squared, and find the square root of 17. So the values that we get are approximately 14.6 and 4.1. Both of these values are smaller than 15. Now, some calculators require you to enter the value first. So I would enter 213 and then hit the square root button. As you can see, you get the same values. Okay. We do 17 and then square root. I get 4.1. So you can see that you get about the same values. All right, so let's compare. We know that 15 is the longest length because we figured out the square root of 213 and the square root of 17. So we get 15 is less than 18.7. That means that we can make a triangle. Now the question is, do we make a right obtuse or acute triangle? So for that, we need to, again, look at the Pythagorean theorem, and we're going to square each length. So 15 is the longest length, so we're going to put that on the left-hand side. 15 squared, how does that compare to the square root of 213 squared plus the square root of 17 squared? Now, remember that squaring and square root are inverse operations, so these two will end up canceling each other out. So on the right-hand side, I will end up with 213 and 17. So 15 squared is 225. And how does that relate to 213 plus 17? 213 plus 17 is 230. So 225 is smaller than 230. So the longest length of this triangle squared is smaller than the sum of the squares of the two other sides. So that means that we form an acute triangle. Okay, so to figure out if we can have a triangle using three different side lengths, we first use the triangle inequality. So we pick the longest side and then compare it to the sum of the two other sides. And to determine the type of triangle that we form, we're going to square each side and compare the sum of the two smaller sides to the longest side squared. Okay, so remember that we're always going to be comparing the longest side squared, and how does that relate to the second side squared plus the third side squared? If you get left-hand side equal to the right-hand side, you have a right triangle. Left-hand side greater than the right-hand side, you have an obtuse triangle. And the left-hand side smaller than the right-hand side, you have an acute triangle. And notice that my left-hand side, I'm referring to the longest side squared.